Hi guys, welcome back to Anjali's Math Desk. In today's video, we will be continuing with rational numbers. Now the first thing we will discuss today is role of 0. Now let's look at 3 plus 0 equals 0 plus 3, which equals 3. This is, again, addition of whole numbers. And now let's look at 4 plus 0 equals 0 plus 4, which equals 4. And now let's look at minus 8 plus 0 equals 0 plus minus 8, which equals minus 8, which is addition of integer. And now let's look at 4 over 5 plus 0 equals 0 plus 4 over 5, which is 4 over 5, which is addition of rational number. Now, what do we see? We see that a plus 0 equals 0 plus a equals a, where a is a whole number. B plus 0 equals 0 plus b equals b, where b is an integer. And c plus 0 equals 0 plus c equals c, where c is a rational number. Therefore, we can say that 0 is the identity for addition of rational numbers. So therefore, we can say it is the additive identity of rational numbers. 0 is the additive identity. Remember the word additive identity of rational numbers. Now let's look at the role of 1. Let's look at 5 times 1 equals 5, which also equals 1 times 5, which is multiplication of a whole number. Now let's look at minus 2 over 3 times 1 equals minus 2 over 3, which equals 1 times minus 2 over 3. Multiplication of a rational number. And now let's look at 3 over 4 times 1 equals 3 over 4, which is equal to 1 times 3 over 4. Therefore, we see that a times 1 equals a, which equals 1 times a for any rational number a. Therefore, we can say that 1 is the multiplicative identity for rational numbers. Now, what about integers? If we look at minus 3 times 1, it equals minus 3. And if we say 1 times minus 3, it also equals minus 3. Therefore, we can say that minus 3 times 1 equals 1 times minus 3 equals minus 3. So since a times 1 equals 1 times a equals a, therefore 1 is the multiplicative identity of integers as well. Now let's look at whole numbers. For whole number, 3 times 1 equals 3, and 1 times 3 equals 3. Therefore, we see that since a times 1 equals 1 times a equals a, 1 is also the multiplicative identity of whole numbers. Now let's talk about negative of a number. What is negative of 1? Negative of 1 is minus 1. Why? Because 1 plus minus 1 equals 0. Equals minus 1 plus 1. Similarly, negative of 3 is minus 3, because 3 plus minus 3 equals 0, which equals minus 3 plus 3. Now, this negative of a number is also called the additive inverse of a number. The negative of a number is also called the additive inverse of a number. So if we were to generalize this, for any integer a, we have a plus minus a equals 0, which equals minus a plus a. Therefore, minus a is the additive inverse of a, and similarly, a is the additive inverse of minus a. Now let's look at rational numbers. Let's say we have rational number 4 over 5. In this case, 4 over 5 plus minus 4 over 5 equals 4 plus minus 4 over 5, which is 0 over 5, which is 0. And minus 4 over 5 plus 4 over 5 equals minus 4 plus 4 over 5, which is 0 over 5, which is 0. So now we can generalize this by saying for a rational number a over b, where a and b are integers and b is not equal to 0, a over b plus minus a over b equals minus a over b plus a over b equals 0. Therefore, we can say that a over b is the additive inverse of minus a over b, and minus a over b is the additive inverse of a over b. Now let's talk about reciprocals. What are reciprocals? What number should you multiply with 7 over 9 to get 1? Now, since 7 over 9 times 9 over 7 equals 1, we can say that we should multiply 9 over 7 with 7 over 9 in order to get 1. Now, let's look at minus 2 over 3. What should you multiply with minus 2 over 3 in order to get 1? In a similar way, we'll see that we will have to multiply minus 3 over 2 in order to get 1. So we can say that the reciprocal of 7 over 9 is 9 over 7, and the reciprocal of minus 2 over 3 is minus 3 over 2. Therefore, if we were to generalize this, we can say that the reciprocal for a rational number a over b is p over q if a over b times p over q equals 1. Reciprocal is also known as multiplicative inverse. Now let's look at distributivity of multiplication over addition for rational numbers. Let's look at rational numbers minus 1 over 2, 1 over 3, and minus 2 over 5. In this case, minus 1/2 times 1 over 3 plus minus 2 over 5 equals minus 1/2 times 5 plus minus 2 times 3 over 15, which is minus 1 over 2 times minus 1 over 15, which is 1 over 30. Also, minus 1 over 2 times 1 over 3 plus minus 2 over 5 equals minus 1 over 2 times 1 over 3 plus minus 1 over 2 times minus 2 over 5, which equals to minus 1 over 6 plus 1 over 5, which further equals to minus 5 plus 6 over 30 equals 1 over 30. We see that LHS equals RHS. Therefore, we can say that minus 1 over 2 times 1 over 3 plus minus 2 over 5 equals minus 1 over 2 times 1 over 3 plus minus 1 over 2 times minus 2 over 5. Now let's use all these concepts we just learned to solve a few questions together. The first one will be 9 over 16 times 4 over 12 plus 9 over 16 times minus 3 over 9. This can be written as 9 over 16 times 4 over 12 plus minus 3 over 9. So we can simplify this equation a little bit, and we can say 1 over 3 minus 1 over 3. You can say 9 over 16 multiplied by 1 over 3 plus minus 1 over 3, which is 9 over 16 times 0, which is 0. Now let's work through examples of additive inverse. You remember from the definition of additive inverse, additive inverse has to be such that a plus minus a equals minus a plus a equals 0. So now, what is the additive inverse of 4 over 5? Let's say the additive inverse is a over b. Therefore, 4 over 5 plus a over b has to equal 0, which implies that a over b is actually minus 4 over 5. So the additive inverse of 4 over 5 is minus 4 over 5. And now, similarly, what is the additive inverse for minus 9 over 14? Again, let us assume that the additive inverse for minus 9 over 14 is a over b. Therefore, it has to satisfy the equation minus 9 over 14 plus a over b equals 0, which implies a over b will be 9 over 14. So therefore, the additive inverse of minus 9 over 14 is 9 over 14. Now let's verify that minus of minus x is same as x for the following. X equals 4 over 9. So since x equals 4 over 9, therefore minus x will be minus 4 over 9. And since 4 over 9 plus minus 4 over 9 equals 0, therefore this same equation shows us that the additive inverse of minus 4 over 9 is 4 over 9, or minus 4 over 9, which implies minus of minus x is actually x. Now let's work through some more examples. Let's find the value of 2 over 5 times minus 3 over 7 minus 1 over 14 minus 3 over 7 times 3 over 5. Now we have learned in the past that rational numbers are commutative. Therefore, by commutativity, we can rewrite this equation as 2 over 5 times minus 3 over 7 minus 3 over 7 times 3 over 5 minus 1 over 14. And now we can say the 2 over 5 times minus 3 over 7 plus minus 3 over 7 times 3 over 5 plus minus 1 over 14. We can definitely write it like this, right? So now we also know that rational numbers are distributive. So by distributivity, we can rewrite this equation as minus 3 over 7 times 2 over 5 plus 3 over 5 plus minus 1 over 14, which further equals to minus 3 over 7 times 5 over 5, which turns out to be 1, plus minus 1 over 14, which now is minus 3 over 7 plus minus 1 over 14, which is a very simple equation that can be easily solved. So minus 3 times 2 plus minus 1 over 14, which is minus 6 minus 1 over 14, which is minus 7 over 14, which is minus 1/2. Therefore, the solution to this equation is actually minus 1 over 2. Now let's look at another example. Let's find the value of 2 over 5 times minus 3 over 7 minus 1 over 6 times 3 over 2 plus 1 over 14 times 2 over 5. Now again, by commutativity, we can rewrite this equation as 2 over 5 times minus 3 over 7 plus 1 over 14 times 2 over 5 minus 1 over 6 times 3 over 2. And now, using distributivity, or the distributive property, we can say that 2 over 5 multiplied by minus 3 over 7 plus 1 over 14 and then minus 1 over 6 times 3 over 2. And we can solve this like so. Over 14 minus 1 over 4, which equals 2 over 5 times minus 6 plus 1 over 14 minus 1 over 4. And now when we simplify it, 2 over 5 times minus 5 over 14 minus 1 over 4, which turns out to be minus 1 over 7 minus 1 over 4, which equals minus 4 minus 7 over 28 equals minus 11 over 28. Therefore, the solution to this problem is minus 11 over 28. Now let's work through the additive inverses of the following. The first one is minus 5 over 9. So the additive inverse of minus 5 over 9 will have to satisfy the equation minus 5 over 9 plus a over b equals 0, which means a over b equals 5 over 9. Therefore, the additive inverse of minus 5 over 9 is 5 over 9. And part B, 19 over minus 6. So again, minus 19 over 6 plus a over b equals 0, which means a over b is plus 19 over plus 6. Therefore, the additive inverse of 19 over minus 6 equals 19 over 6. Now let's move on to the next question, which is verify minus x equals x for minus 13 over 17. Now, in this case, we see that x is minus 13 over 17, which implies that minus x will be minus of minus 13 over 17, which is 13 over 17. And since minus 13 over 17 plus 13 over 17 equals 0, this equation shows us that the additive inverse of 13 over 17 is minus 13 over 17, or minus of minus 13 over 17, which implies minus of minus x equals x. Now let's work through some of the multiplicative inverses. The first one being minus 13 over 19. Now we know in order to find the multiplicative inverse of a number, we have to make sure that the equation minus 13 over 19 times a over b equals 1. So therefore, in this case, a over b turns out to be minus 19 over 13. Therefore, since a over b times p over q equals 1, we can say that p over q is the multiplicative inverse of a over b. So in this case, minus 19 over 13 is the multiplicative inverse of minus 13 over 19. And now let's work through the second example, which is minus 5 over 8 times minus 3 over 7. This turns out to be 15 over 56, So 15 over 56 times a over b equals 1. Therefore, a over b equals 56 over 15. Therefore, the multiplicative inverse in this case is 56 over 15. Now, let's multiply 6 over 13 by the reciprocal of minus 7 over 16. So, first of all, what is the reciprocal of minus 7 over 16? Again, reciprocal is the same thing as the multiplicative inverse. Therefore, multiplicative inverse or reciprocal of minus 7 over 6 can be found using minus 7 over 16 times a over b equals 1, which implies a over b is minus 16 over 7. Therefore, the reciprocal for minus 7 over 16 is minus 16 over 7. And now, going back to the question, which is multiply 6 over 13 with the reciprocal of minus 7 over 16, which implies multiply 6 over 13 with minus 16 over 7. And this literally just turns out to be minus 96 over 91. Therefore, 6 over 13 times minus 16 over 7 is minus 96 over 91. Now let's look at our next question. Is 8 over 9 the multiplicative inverse of minus 1 over 8? Now first of all, what is minus 1 over 8? Minus 1 over 8 is a mixed fraction, which we will solve using the properties that we are already aware of. So minus 1 times 8 plus 1 over 8, which is minus 9 over 8. And now, since 8 over 9 times minus 9 over 8 results in minus 1, therefore 8 over 9 is not the multiplicative inverse of minus 1 over 8. Now let's work through another example. Is 0.3 the multiplicative inverse of 1 over 3? So what is 1 over 3 first of all? It's 3 times 3 plus 1 over 3, which is 10 over 3. And 0.3 can be written as 3 over 10. Now, since 10 over 3 times 3 over 10 equals 1, therefore, we can say that 0.3 is the multiplicative inverse of 1 over 3. So this brings us to the end of our second video. If you guys do like my video, please do not forget to hit the like button, leave the comment, and subscribe to my channel. Also do hit the bell icon so that you never miss a video ever again. Bye for now.